Hi, I'm going to be showing you how to do this free response problem from 2009, Form B. And for this one, you are not allowed to use a calculator. So the problem reads, let R be the region bounded by the graphs of y equals root x and y equals x over 2 as shown in the figure above. So for part A, find the area of R. So we're finding this area. In order to find the area between two curves, first we have to determine what the top function is and what the bottom function is. So if you look at the graph, if you remember the graph of root x, we know that graph looks like this. So now we know that the top function is going to be root x and the bottom function will be x over 2. So to find the area between two curves, you have to do the integral. So you're going to have to take the integral from a to b, which are the x values, so that would be 0 to 4 in this case, but I'm just going to say the formula right now. So the integral of a to b of the top function minus the bottom function. So that's just the general formula to find the area between two curves. So now we're going to plug this in. So in our case, we'll be taking the integral from 0 to 4 of top function root x minus bottom function x over 2 dx. So to solve this, we take the integral of each of these functions first. So the integral of root x is going to be x to the 3 halves, and then you just counterbalance with that with 2/3, and then minus the integral of x over 2, which is x squared over 4. So now you're going to want to plug in these limits. So you're going to want to plug in 4 and 0, and you always plug in 4 first and subtract it from 0. You always do top minus bottom. So if we do this, if we plug this in, it would be 2/3 times 4 to 3 halves minus 4 squared over 4. And this is, when you plug 4 in, subtract everything when you plug 0 in, which will end up being 0, but for free response you want to show that you know what to plug in where. So for free response you can leave it like this, but I'm going to go ahead and solve it just so that you can also see what the answer is. So for this area, this part right here becomes 16 over 3 minus 4 squared over 4, which is 4, and then minus 0 because this whole section becomes 0. Then you would just, find a common denominator, so 16 over 3 minus 12 over 3 equals 4 over 3. So that is the answer to A. Okay, so B. So for B it says, the region R is the base of a solid. For this solid, the cross-sections perpendicular to the x-axis are squares. Find the volume of this solid. All right, so for part B, we're trying to find the volume of a solid with a known cross-section. And it says in the problem that those are squares, those cross-sections are squares. So the general formula for this that you have to know is, again, the integral from a to b of, and you still keep it from top minus bottom, but you would square it because for squares, the formula for square is is base times height. So this is the general formula for cross-section of a square. So now we're just going to plug in what we have. So the volume is going to equal same limits 0 to 4 of root x minus x over 2 squared. So for this one, you actually want to square like this whole thing. You can't just distribute that. No, you cannot do that. So you're gonna actually have to multiply it out like this. And once you do this, you end up getting x minus x to the 3/2 plus x squared over 4 dx. So again, you take the integral of each one. This one becomes 1/2 x squared minus x to the 3/2 becomes 2/5 x 5 over 2, and x squared over 4 becomes x to the x cubed over 12. And then you follow the same process as in A, and you plug in the limits. Plug in 4 first. 1/2 times 4 squared minus 2/5 4 5 to the 5/2 plus 4 cubed over 12. So that's 4, and then subtract, and you plug in 0. 5 over 2. So again, for this one, this whole part goes to 0. That doesn't happen in every case, but in this one it does. And so when we work all these out, it becomes 4 squared times 1/2 is 8. Then this one, 2/5 times 4 to the 5/2 becomes 64 over 5. Some of these are kind of ugly numbers, but once you simplify them, it gets better. So, and 4 cubed over 12 becomes 64 over 12. And I just simplified this even more. 64 over 5. This one I just made into 32 over 6. And then you just find the common denominator like in part A here, and it ends up being 8 over 15. And that's your answer for B. But because it's free response, you can also just circle your answer right after you plugged in the limits right here. And that should be fine, just so you don't make any mistakes between here and here. But that's the answer for B. Now, C. Write, but do not evaluate an integral expression for the volume of a solid generated when R is rotated about the horizontal line y equals 2. So for C, what we have to do is we just have to write the expression for the volume of R when it's generated around y equals 2. So for C. The moo cow you have to know for this one is the washer method. And washer method is used for solids of revolution. So whenever you see something that says rotated around x-axis or whichever line, you typically have to use the washer method. So the washer method, the formula for this is volume equals pi, because you're rotating around a certain line, of the integral from a to b of the top function squared minus the bottom function squared separately, dx. So this is the basic one used for if you're rotating around the x-axis, but if you're rotating around a specific line that they give you, then you have to incorporate this later in the formula, which I'll show you. So one thing you have to be careful about with when rotating around something other than the x-axis is you have to make sure you know which one is the top and the bottom function. So right now, the graph looks like this kind of, and so y equals 2 is up here. So then once you rotate this around, the y equals 2 line, the function is going to look, something like this. So now we know that root x is the bottom function now, and x over 2 is the top. So we have to make sure we switch those around when we're writing the equation, because it's different than before. So when we plug in everything to the equation, it becomes pi integral of 0 to 4. It's still the same, 0 to 4. And then this is when you incorporate the y equals 2. So you would first take the 2, the line, and subtract it from the top. And so now we just found that the top equation is x over 2. So you do that, and make sure you square that. Then subtract 2, again, the line they give you, minus root x squared and dx. And that is the answer for that one, because we just have to write the equation and we don't have to evaluate it. So, yeah, that is how you solve this problem for the area between two curves.